Hey guys, so in this video we are going to be focusing on collecting data, sourcing data, and we're going to just briefly talk about what big data is. So first, let's just review what data is. So data is a collection of facts. That could be anything. It could be numbers, it could be words, it could be measurements, descriptions, observations, pictures, videos, audio, really anything. Just a collection of facts or a collection of information. So there are two different types of data. There is structured data and unstructured data. So structured data is just that. It's very structured. You could think of spreadsheets being structured data. So you have a header at the top for each column. So in this case, it's the rank this week, the song and artist. I believe this is the Billboard Top 100s. And then below are rows of data that apply to that particular column. So this column is going to be all artist data. This column is going to be all song data. And this column is going to be the ranking data. Unstructured data is just the opposite. It's not very organized. It's not very structured. You don't know. You can't anticipate what is coming next in the data. So song lyrics or letters or email, text and email are all unstructured data. It's data, it's information, it's a collection of facts and information, but it's just a string of information, a string of text. It's not categorized by any specific category. So it's hard to determine what's going to become next. So if you don't already know this song, you don't know what the next line of this song is going to be. So let's just go through a few different options of data sets and figure out if it's structured or unstructured data. So this is Major League Baseball statistics. So we have the Cincinnati Reds and the San Diego Padres and all the data associated with all the players on those teams. So this is actually very structured data. We have rows and columns. That's a really good hint to see if it's structured or not. At the top, we have headers. So we have the hitters. So these are all the players on that particular team that had at-bats. The AB is the number of at-bats, then the runs, hits, RBIs, based on balls. Then below that are all the values for that particular type of data. So the hitter is the person's name and the position. Then the number of at-bats, the number of runs, the number of hits, number of RBIs, etc. So this is actually Bitcoin data. So this data is fairly structured too. We don't have a header row of descriptive text to explain what each column is, but you can kind of determine what the data is and kind of guess as to what the next possible type of data will come next. So we have the timestamp, and I believe this is the person that is sending the Bitcoin. So this is their ID. I think this is a value. This is someone receiving it. I'm not sure what the last one is. And I think this is the transaction ID. But if you go to the next line, it's pretty much the same as you keep on going down. So you can kind of predict what type of data is going to be next. Twitter. So Twitter is kind of like a mix of structured and unstructured data. So if you look at the tweet itself, the text itself, that is unstructured data. If you look at the metadata around the tweet, we have the person's name, the person's Twitter handle, the total number of their followers, etc., etc. That is all very structured data. So if you look at someone else's Twitter page, then you can determine that they also have a name, they also have a Twitter handle, they also have total number of followers, and they also have tweets. So the metadata around the tweet is very structured, but the tweet itself is unstructured. So this is an email, and this email, the text itself, is unstructured. This email is actually part of an FBI investigation on Enron back in, I think, the 1990s. They were under investigation for nefarious activities with their business. And most of the evidence against them were emails sent back and forth between the people that worked at Enron. So the emails themselves are really hard to kind of parse through and get insight from. But every email that you send out has metadata behind the scenes that is very structured and very easy to go through. So it has information around who sent this email, who did they send it to, timestamp when it was sent, when it was received. So with all this information, you can determine who's communicating with who, when they're talking, and then based off of that, you can kind of narrow in on the emails that you really want to dig into. So rather than looking at millions and millions of emails and trying to parse through all that information, you can kind of narrow it down by looking at the metadata first and have a smaller number of emails to actually read through. So it just makes your life a lot easier as an investigator looking into this issue. So the email itself, again, is very unstructured. So the text in the email is very unstructured, but the metadata behind the email is very structured. Images. So images are very similar to the email example. So the image itself is very unstructured when you look at like the pixels and trying to determine what color pixel is going to be next. But the image also now has lots of metadata associated to it. So any photograph you take on a modern camera or a camera on a smartphone attaches metadata to it. So this picture has a story behind it. This is an image of John McAfee, who was the founder of McAfee Security Software. And he's on the left, and the person on the right is a reporter for Vice News. The story behind John McAfee is that he had been accused of being a part of a crime, I believe it was a murder, and fled the country rather than talking to the authorities about their investigation. So he was on the lam for a little while, and this Vice reporter found out where he was, decided to track him down and reach out to him for an interview, which he agreed with. And in the article that he posted around this interview, he posted a photograph that he took with John McAfee. But he didn't strip out any of the metadata behind this photograph. So metadata behind images include what camera it was, the photograph was taken on, the lens used, the exposure, the date when the image was taken, but it also includes a location, a latitude and longitude location. Basically, this reporter outed where John McAfee was to the entire world if they looked at the metadata behind the image. Let's do a little history of data collection. So this is the Blombos ochre plaque, which was found in a South African cave, Blombos Cave in South Africa. And it's the oldest example of data collection. That's disputed by some people, but a lot of researchers and historians believe that this is one of the oldest, if not the oldest, example of data collection. So this dates back from before 75,000 BC. Although it looks like just a pattern, most people believe that these markings represent a count of some kind, a tally. Ever since then, people have been keeping track of days and hunting kills and kills in war, among other things, by doing markings on stone or wood or collecting teeth, for example. So John Grant was a haberdasher by trade, but in 1662 he was asked by the City of London to create a list of all the deaths that were happening in that city and the reasons behind the departures. So this list helped them better understand the plague and how it spreads. So this kind of led to the creation of public health and epidemiology to determine, based on data, where these diseases are coming from and how they're being spread. And with this information, you can better put a stop to it and eliminate the disease completely. So in 1890, Herman Hollerith decided to come up with a better way and a more efficient way of collecting data. And he was actually inspired by the jacquard loom. which was created by Joseph Marie Jacquard. And this loom was really revolutionary because it used punch cards to actually create the image on the loom. So if there was a hole in the punch card, then it would create a stitch. If there wasn't a hole, then it wouldn't create a stitch. So basically, you can reproduce the same image over and over and over again with the punch cards and the holes in the punch cards much faster than doing it just by hand. Herman Hollerith decided to take this process of using punch cards to store and collect data. So this was a new and more efficient way of collecting and ultimately analyzing large amounts of data. He also used a large number of women to actually create these punch cards, and these women were called computers. So this was the precursor to the modern computer. And as you might have guessed, these were the early forms of computers we use today. So punch cards are basically just zeros and ones, binary, right? So if there's a hole, it's 1. If there's not a hole, then it's 0. So our computers actually still use this logic of binary today. So Herman Hollerith actually created this into a company which later became IBM. So after the invention of the computer, there was no way for one computer to communicate with another one. So we actually had to build a network to have them connected and be able to communicate with each other. So in 1982, the internet was created by a number of researchers and scientists at universities around the United States and was funded by the United States government. So ultimately, the internet is just a bunch of cables that are running, well, now around the world to connect one computer to another. The majority of them today are underwater sea cables that are connecting continents too. And then internet providers like Verizon and Comcast lay the wires to connect the households. So we had all these connections with all their computers now with the internet. But at the time, it was really difficult to easily communicate with these machines for free. So it wasn't until Sir Tim Berners-Lee created the World Wide Web in 1989, along with HTTP, which is a hypertext transfer protocol, and HTML, which is hypertext markup language, and hyperlinks to link all these websites together, that it made it much easier for anyone to communicate and connect with everyone else around the world. Before the World Wide Web was created, everything was proprietary to get onto the internet. So you basically had to pay a lot of money to connect to the internet. The great thing about the World Wide Web is that it was created and given to everyone for free. So it gave everyone with a computer access to communicate with each other and share files much more easily and much cheaper. So today, pretty much every company is a data company. If they have an online presence, which pretty much every company does, they are collecting data, whether that's just data around who's coming to their website, data around users uploading information to like Facebook or Twitter. Every company is collecting data in some way through their websites. They're not only collecting data around information that you are giving to them intentionally, they're also collecting data on, for example, your location and determining where you are going. And based off of this information, they can do whatever they want. They can sell you new things. They can target advertisements to you based off of where you're going and who you're spending time with and what city you're in, etc. So whether you have an iPhone or an Android phone, these apps on your phone are most likely tracking where you go, what you're doing, what you're looking at. And based off of that information, they can do whatever. They can sell you stuff or serve ads to you, etc. So a friend of mine actually created a project around this idea of all these companies profiting off of your information. Federico Zanier created a Kickstarter to sell his own data, his own personal data, to basically try and monetize it just like these large organizations, large tech companies were doing. He did it more as just a comment on the idea that all these companies are profiting and making billions of dollars off of data that they're collecting on you. but we aren't seeing any of those dollars, essentially. They're not paying us for our data. They're just taking it from us, or we're giving it to them for free. I'll add the link to the video for his project so you can learn a little bit more about it. It's really interesting. The link should be below this video in the description text. So today, while we're living through a pandemic of COVID-19, coronavirus, data is very important. So we are tracking everything about this virus from where people are testing positive for coronavirus, where people are dying of the virus, and determining where there's hotspots, where there's flare-ups, how this thing is spreading. And based off all that information, we can better fight this virus and save lives, really. By determining where it's being spread, we can implement laws that people have to stay home, implement laws around wearing a face mask, face covering of some kind to stop the spread or at least slow the spread. So data, when it comes to the coronavirus, is hugely important for fighting this virus and getting rid of it, or at least reducing the total number of people that are testing positive for it and ultimately dying from it. So Johns Hopkins University of Medicine has a really great resource when it comes to tracking the coronavirus in the United States as well as globally. And then you can also look at your own state. You can look at data across the entire United States. You can look at counties and get really detailed with it. The New York City Department of Public Health also has data around New York City coronavirus positive rates as well as death rates. And all that data is publicly available on their GitHub account. So if you wanted to see what's going on when it comes to the coronavirus in New York City, then you should check out this data. They break it down by age, by borough, poverty, race, gender, etc. So it's really interesting to see it, especially since this is basically where we live. So I would definitely suggest checking this data out if you're interested in data collection for the coronavirus. So in this class, we are going to be collecting our own personal data throughout the entire semester. And the person that comes to mind when it comes to quantified self and data collection around your own information is Nicholas Felton. Nicholas Felton is a data visualization designer, artist, and he came to fame by basically collecting his own personal data over the course of a year. And then at the end of each year, he would design and publish a personal annual report. So there's a really great interview with him on the New York Times, which I will also link to in the description below. So make sure you check that out when you have a minute too. So when it comes to collecting data, there's a lot of different apps and platforms that you could use to collect your own personal data. So Moment app is a really great one when it comes to analyzing what you are doing on your phone, your mobile device. So how many times you're picking it up, how long you're looking at your screen, how long you're using your phone, and it's broken into each day. Rescue Time is a really great platform that allows you to track what you're doing pretty much on your computer. So what websites you're going to, what software applications you're using, how often are you using them. Based off of that information, they could also tell you how productive you're being throughout the day. The Feltron Reporter app is an app created by Nicholas Felton, which is an app that basically allows you to track what you're doing throughout the day. It's kind of like a diary, but you can automate certain things, and it just makes it a lot easier to track your information, how you're doing and what you're doing. I believe that one is the only one that is a paid app. All the other ones I'm suggesting are free. And then Apple iPhone health sensors and the health app on your iPhone allows you to track how many calories you're burning, if you're exercising, how many flights of stairs you walked up, how many steps you took in a day, and you could also export all of this data really easily. One app that I highly recommend that unfortunately is now a paid app, paid service, is Gyroscope. Gyroscope basically tracks your location. That's one great thing. There's places. It tells you everywhere you're going and everywhere you have been. But you could also connect your Instagram account to it. You can connect your Apple Health data to it, aggregate everything into one location. So this is a really great tool that I highly recommend. I'm not requiring anyone to purchase it, but if you have the means and have the interest, then I would recommend downloading it and getting a subscription. So one great thing is that the European Union came out with these new laws and regulations for tech companies called GDPR, General Data Protection Regulation, that required any tech company, any website basically that's operating in the European Union to allow their users to see all the data and download all the data that they collect from their users. As well as allow them the right to have you delete any sort of information that they have collected on you. So due to the GDPR, we can now download all the data that Apple has on us, or download all the data that Facebook has on us, and be able to analyze that ourselves and see the content that they're collecting around our own use of their platforms or products. So there are a lot of different wearables that you can buy now that allow you to track your movements, your exercise, your heart rate. So some of these, actually I think some of these are no longer in existence, but there's the Fitbit, the Jawbone, Nike Fuel Band, and Apple Watch, just to name a few. And these are becoming more and more popular when it comes to tracking our movement information and our health data. So with the Apple Watch, that connects to your iPhone, which connects to the Apple Health information. So all the information that you collect on your Apple Watch, you can then download from the Apple Health app and use for your own purposes. There's lots of other hardware when it comes to data collection. So Automatic is a device and an app that tracks everything that has to do with your car. There's the Muse headband, which is really interesting. It tracks and collects your brain waves, and you can control an app with your mind, essentially. There's the Nest products. The Nest thermostat, anyway, allows you to change the temperature on your thermostat, but also through machine learning, it remembers what your preferences are for different times of day. So if you like it warmer in the afternoon, but colder in the evening, it'll remember that and set it for you. And then there's another device called the Vessel, which is interesting, which was a cup that could detect what liquid you're pouring into it and tell you like how many calories are in your coffee or your beer that you're drinking. So now we have most of our devices that we wear, that we use, and that we have in our home are all connected to the internet in some way. These are called the Internet of Things. So we have like toothbrushes that are connected to the internet. We have air conditioners that are connected to the internet. We have tons of different products that we buy now that are all connected to the internet in some way. And all of these products are sending data to and from the device and back to the company that created the device. So they actually have all this information about how often we're brushing our teeth or turning on the air conditioning, and can use that data for any purposes that they want. That could be good or bad purposes. It could be for advertising. It could be for selling us dental insurance, for example. So this journalist actually created a device that allows you to track all the data that is being sent to and from these companies and to and from these devices. So it's a really interesting read. You should check out this article. And there's another article attached to it that teaches you how to create this little device using a Raspberry Pi and do this yourself. So you could track all the different devices and all the data that's being sent to and from them in your apartment or house. So there is a great documentary series called The Dark Net that was co-created by Showtime and Vocative. It's basically looking at the internet in a different perspective. There's this one episode called The Connected Us that is looking at personal data collection, and then it interviews this guy who is obsessed with collecting all of his own personal data. So I will link to this video in the description below. And if you do have Showtime and have the ability to watch this series, I highly recommend it, especially for this class. It's really interesting and enlightening. Lastly, I just want to talk about a project that a friend of mine put together. It's called CH4, and it's kind of a comment on all of these different connected devices and wearables that have been popping up in the market lately. This particular device tracks your farts. So if you pass gas, then it's going to detect that with this device that you hook to your back pocket or to your belt and track the amount of times that you pass gas throughout the day. So it's kind of an absurd, maybe useful for some people, device that he created and actually works and put it on Kickstarter. It didn't go to production or anything like that. Again, I believe it's just more a comment on the absurdity of all these devices that are connected to the internet. There is a great video, and the Kickstarter website is still live, so I will link to that in the description below as well for you to check out on your own time. So the internet was not just to bring joy to the world in the form of cat memes, although it might seem that way. And actually, to be honest, the internet is mostly cat memes. A Stanford professor did research around looking at YouTube videos to identify different objects in those videos. And he ran this really intense neural network around stills from all these videos. And on the right-hand side is what it came back with. So basically, the majority of YouTube videos and probably the majority of the internet is created for cat lovers. It's nothing but cat memes and videos. But there's also other really great stuff on the internet as well, and is really the main source when it comes to finding data that's already been collected and already been put out there. So the first type of data that we're going to talk about are open data sets that are basically data sets and spreadsheets that you can find online that you can just download and use. So here are some examples of places where you can find lots of open data sets. So if you're really interested in New York City data, like what is the reason for my favorite restaurant getting a C rating, you can find all that information on the New York City Open Data website. If you're really interested in the United States data, then you can check out the Census website. If you're really interested in like crime data, you can check out the FBI website. And then if you're interested in global data, you can check out the World Bank website and all the data sets associated to it. Most of the time you're going to find open data sets are going to be in these three different formats. So it's going to be a CSV file, which is comma separated value, TSV, which is tab separated value, then Excel files. These are all table-based formats. So any one of these you can download and then open up in Excel or Google Sheets or Numbers, really any software that is a spreadsheet software. So beyond open data sets that you can just download and start using, a lot of websites have data on their website. So some of this data can be easily copied and pasted into a spreadsheet, but only when it's in a table, HTML table format. So like the baseballreference.com, all the data is in a table format. So you can just highlight that and then do copy and then paste it into a Excel file or Google Sheets, just spreadsheet file. But there's also some websites that have data displayed in a more complex format, like the Billboard Top 100. So that isn't as easy to copy and paste and start using. But there are platforms and methods that you can use to scrape that data and put it into a spreadsheet format. So one platform is called Data Miner, which is a really great plugin and piece of software that allows you to select different data types. So if I wanted to get the rank, the name of the song, and the name of the artist, then I would just click on each one of those and identify that particular HTML object as the data, and then I'll find all the ones that are similar and then copy that and put it into a spreadsheet for you. You could also use Python if you're comfortable with programming. There's a library called Beautiful Soup that is created for Python to scrape websites and the data on websites. Why don't we do a little demo of just simply copying and pasting tables from a website into, let's do both Excel and Google Sheets. So let's just go to baseball-reference.com. So why don't we do something a little closer to home? Let's look up the Mets, New York Mets, see their data. And let's see their year-over-year stats for, let's do batting average. So if you go down here, you can see that this is a HTML table. So the obvious way to know that is that you have a row and columns of data. So here, if you just click and drag to select what you want, highlight it, and then go to copy. And then if you go to Excel, let's do Excel first. Let's create a new document. And then you can just go to paste if you wanted to. The thing with that is that pastes in all the HTML as well. So let's do that first. So you see all the coloring here, and then these are hyperlinks. Let's not do that. So there's another option. If you go to Edit, Paste Special, then instead of doing HTML, you could do text. So it's going to strip out all of the HTML content. Hit OK, and then it's just raw data, just the values. So that's the easy way to do it. And let's just do it in Google Sheets too, just so I am not choosing one over the other. So here, unfortunately, you can't just do paste values for some reason when you're copying from website to Google Sheets. Let's try it. Yeah, that doesn't work. So you just have to do regular paste. Let's do Command V. And that still pastes in all the HTML. So if you want that, that's great. If not, then there's another way to do it. So if you select all this, do Command A and then copy it again. And then let's just create a new sheet. You could create a new document if you wanted to. And now, for some reason, you can go to paste special and then paste values only. And this is just going to strip out all the HTML, so it's just raw data again. So it's that simple. All you have to do is select the data in the HTML table, copy it, and then paste it into Excel or Google Sheets. So what if you wanted to do something a little bit more advanced? So if there wasn't a easy to read HTML table, easy to copy HTML table on the website. Let's say we're trying to get the data from the Billboard charts top 100. So this data is not in a HTML table. It's in like divs and paragraphs, and it's styled in a more complex way. So to do that, it's not much harder. It just requires one more step. So you could either do this with code in Python and write some HTML scraping, web scraping code, or there's a really great tool called Data Miner. Data Miner allows you to basically more easily do web scraping rather than writing code. You just kind of click on different elements that you want to scrape and then hit go, and it scrapes everything that's related to what you selected. So all you have to do is go to data-miner.io, create an account. It's a free account, and then you can add the Chrome extension. It only works in Chrome, unfortunately. And once you have that set up, then you're good to go. So let's go back to the Billboard Top 100 site. And then I'm going to click on the Data Miner Chrome extension. And they call their they call it when you scrape data from a website, or a recipe. So we're going to create a new recipe. And we are going to do a list page, it's fine, and go to rows. So we're going to find the row that we want to scrape. So basically we want to find everything that is similar to this styling at the top. So these are the ranks, this is the name of the song, this is the name of the artist, then last rank and peak rank, etc. So we want to find that parent container that holds all of that data for our rows. So for this, we can hover over each one, and then what we like, we can hit shift, and then it's going to give us some elements. So what it's looking at here is HTML classes and element types and IDs. And these are unique identifiers that they're going to use for finding all of the data on the website and then scraping it using those classes or element types. So I'm going to go to the parent. I'm going to go a little bit higher. And now you can see that it's selected this entire row at the top. And that's basically going to be, that basically contains all of our data content inside. So it has the rank, it has the name of the song, name of the artist, etc. So let's see, we want to select the element. I think chart element wrapper makes sense. And then when you select that, you can see that it highlights everything below in green, and it's highlighting the right area as well. So that looks correct to me. You can scroll down, just make sure that it's working properly. Looks good. All right, then we hit confirm. So that's going to be our row content. And then we want to select our column content. So the first column, let's do rank. And you could say, yeah, that's going to be text. You can do URL if you wanted, or HTML, or an image URL, etc. Then we're going to do the same thing. We're going to find the element and hover over it and press shift. And then we're going to select the class, which is chart element rank number. That sounds right. Click that. And then it highlights all the ranks below as well. Hit confirm. And then we know we have, we're going to have 100 rows of data. So this is telling us how many rows of data that we have. And it's saying there's 100 in there. So that's great. So we know that's working properly. So let's do another column. Let's do artist. Do text again, find, and then we're going to find the artist. Hover over, hit shift, and chart element information artist. Cool, that looks good. Then let's do one more. Let's do the song. Text, find, hover over the song name, hit shift, chart element information song, that sounds right. And then it selects all of them with that class. Hit confirm, and that should be good. So nav, we don't have to worry about. Actions, we don't have to worry about. JavaScript, we don't have to worry about. So then we just hit run recipe, or you could save it. So let's just save it as billboard 100. Go back and, yeah, looks good. And then save, run recipe. And here's all our data. So it's scraped it all for us. And then we can go to download, and we can download it as a CSV file or Excel file. Let's do a CSV file. And billboard 100. Desktop is fine. Okay. Let's close that. And let's go back to the desktop. And open up the file. Awesome. So we have rank, artist, and song. And we have all 100 in the top 100. Awesome. So the next possible form of data that you're going to come across is in a PDF format. So usually when you're looking at like financial data, like if you want to see how much money Apple made in the last couple of years, it's probably going to be in like an annual report, which is usually a PDF format. So unfortunately, it's not easy to get data out of PDFs, but there is a really great piece of software called Tabula that is a free piece of software that allows you to highlight a table in a PDF, and then it'll automatically convert that into a CSV file, which you can then open in Excel or Google Sheets. So let's go ahead and play around with that. So here is the website for you to download the software. It's tabula.technology. And you can download it for both Mac and Windows. There's a GitHub repo. This is all open source, so you can look at the code and see how it was actually created. And then when you open it up, it's going to open up in the browser window. So it's probably going to open up in Chrome, and it's going to look like a website. But it's running locally on your machine. So it's not like a website hosted somewhere else. So why don't we get some financial data? Let's get some financial data from the Tesla. So really any public company is required to publicly disclose all their financials at the end of each quarter. So if we go to Tesla's financial information website or webpage, we can download the information for 2020. And there's a nice table here that shows their quarterly earnings and profit and gross margins, etc. So let's try and convert that to a CSV file. So you can save this, and then I already downloaded it. So let's go back here. And this is a PDF. So I would also recommend, rather than uploading an entire PDF with multiple pages into Tabula, to just extract the one page or multiple pages that you want to convert. If you upload everything, it's just going to take a long time to process, so it just is kind of pointless to upload stuff you don't need. So I already extracted this table separately. So now we go to Tabula, and we can browse for the file, find it, and then open it. And then we can import that file. Awesome. So now all you have to do is click and drag a box around the table that you want to convert to a CSV file. You can hit preview and export extracted data. And there you go. So sometimes it's not as beautiful and perfect as this. So you have to do some manipulation after the fact in Excel or Google Sheets. And you could also, there's two different options. There's a stream option and a latest option. So you could play around with those two options to see which one looks better. Looks like stream is a little better, a little cleaner. And then you can select the export type. So you can do CSV, TSV, JSON, zip of CSVs. I don't know what script is, but I'm just going to do a CSV, hit export. And let's call this Tesla 2020. Save it to the desktop. Let's go back here. Let's open that in Excel and just check it out. Cool. So there's a column here that shouldn't be here, so you can easily clean that up. But it's for the most part, it's looking pretty good. Cool. All right, so the last option that I want to talk about and show you a little demo on is trying to extract data from an interactive visualization online. So if there's any interactivity to it or any motion, it's probably created using JavaScript and probably has data associated to that JavaScript file, whether it's a JSON file or a CSV file, or embedded in the JavaScript as an array of values. The data is there somewhere. So if it's there, then you can actually find it and use it for your own purposes. So let's take a look at this project that the New York Times did. So this is a visualization looking at all the people in need of help during Hurricane Harvey's flood in Houston. So these are all the different messages from people who are in need of help and assistance, who are like stuck on roofs or just in a bad spot because of the flooding in Houston. So this is all interactive. There's movement to it. So you know that it's not a video. So you know that there's data behind this somewhere. So the easiest way to do it is to go to, in Chrome anyway, go to View, Developer, and View Source. And this is all the source data behind this this website, this web page. So the thing that I like to do is just do a find, so Command F, and then if you do find for like CSV or JSON or .js, see what pops up. So here is one CSV. So this rescues parsed reprojected. That sounds good. So let's open that up. It's a CSV, so we got to download it. And let's check that out real quick. So it has longitude and latitude, date, and I think this is like pixel location on the graphic of where that little dot should be. So that's helpful. So we have all that information. And let's go back. There's also a JSON file here, selected.json. So let's click on that. So this is all the data that's popping up with the text for each person's call for help, essentially. So all the data is here, has the latitude and longitude, timestamp, and then the text that popped up over time as they were sending their message. So again, all the data is there. You can just copy and paste it and use it for your own needs. Sometimes this is more complicated and harder to find the data. So there's another method that you can use as well. So let's do that one real quick too. So why don't we look at some CDC COVID data? That seems to make sense right now to check that out. So the CDC is tracking everything that's going on with COVID-19 when it comes to the cases and the deaths in the United States. And they're tracking it by state level. I believe they're tracking it by county level as well. Here's the data by state visualized as a map. There is a tally for the entire United States for total number of cases, total deaths, total cases per 100 people. Then down here, there is more data in a table format. So if we look at the source, it's CSV, nothing, JSON, nothing that's really helpful, .js. Yeah, a lot of JavaScript files. So they're using D3, which is a visualization platform. Looks like they're also using Tableau, which is another visualization platform. So the other method that I'm going to show you, so if you go to View, Developer, and Developer Tools, this is going to give you all the different developer tools that we have access to. And the one that we want to check out right now is Network. So if we have this set to Network and then reload the page, it's going to display all the different files that are loading in, when they're loading in as well, and breaking it into different file types. So there's XHR, I'm not sure what that stands for. There's JS, so JavaScript, CSS for styling, images, media, fonts, docs. I don't know what WS is. I don't know what manifest is, and then just other files. So let's take a look at XHR. And these are some of the files that are loading in when you load this website. So this looks like this is for the map. So this is state territories. Some more state information, notes, colors. That's probably the colors for the cases down here for the map. CSV info. US map testing. So let's take a look at US map testing. Okay, cool. So this shows all the data for each state anyway, and the total number of tests performed, percent positive range. So you can take a look at all this data, and you could also, if you do control click, you can open it in a new tab and look at it all there too. So that's just another way of finding where this data is coming from, how it's being loaded into this site, and then using it for your own purposes. Cool. Another source of data are using APIs. APIs stand for Application Programming Interface, and basically it's a way for you to use programming to get data from another third-party source like the New York Times or Instagram or Open Weather Map or Twitter. So it basically allows you to get into their data and make a query or a request for the type of data that you want to be sent back to you. So if I wanted to look at weather data in real time for New York City, then I could use the Open Weather Map API to get that data, get that information. And usually you're going to display that on your own website, or maybe you can download it and scrape it from their API. So I do a lot of web scraping for Twitter for a lot of my projects, and using Python, you can scrape tweets and scrape information from Twitter and then use that for your own analysis and projects. So when it comes to data for the web and data with APIs, it's most likely going to be in a JSON format, which stands for JavaScript Object Notation. It could be in XML format, which is similar to HTML, but that's kind of old. Most of the newer APIs and newer ways of having data on the web is going to be in JSON. And JSON is not table-based. It's based on nested data points. So this is what JSON looks like. You have coordinates, and then inside of coordinates, you have the latitude and longitude. Then below that, you have weather, and then main and description inside. And then main is going to be temperature, pressure, humidity, etc. So there are tons and tons of APIs out there that are publicly available for us to use and for free. And there's more and more APIs being created daily. So some APIs are meant for us to use on our own projects. And then some companies actually create APIs to be used internally on internal projects. But most of the APIs out there are free for us to use and are really great when it comes to creating our own projects. It makes it a lot easier. Let's say we wanted to make an app or a website that uses location data and a map. Then we could use Google Maps API rather than creating our own map and our own directions software and data set. So one project that I actually created using two APIs is called fashionweatherready.com. And basically it uses a weather API and a fashion API and mashes them together. So all you have to do is put in your location using your zip code, check whether you want to look at male or female clothing. And then it'll find the weather for the next week in your area. And based off of that data, if it's going to be warm or cold or sunny or rainy, it'll make recommendations on what you could wear for that particular day based off of the weather. So that's one example of using APIs in a creative way. So you're using someone else's data and mashing it together to create something new. And this only took me like a weekend to create because I'm not creating this really intense data set with weather data and fashion data. I'm using something that's been already created, and it just makes it a lot easier and faster to build something based off of that data. Lastly, I just really quickly wanted to talk about big data. So this guy, John Massey, in 1998 created this deck around big data and the next wave of infrastress. And basically what he was saying is that the growing infrastructure and storage brings more and more data. So the more our technology for storing data improves, the more data we are going to create and store. So in 1979 on the left, that is what 250 megabyte hard drive looked like. It was massive and weighed 550 pounds and was very expensive. In 2013, this is what a 16 gig micro SD card looked like. So going from that massive 250 megabyte hard drive to this teeny little 16 gigabit micro SD card in like 30 plus years is pretty impressive. And that 16 gig micro SD card only costs about $11 and was like super small and light. And that was 2013, so this is old, so it's probably much larger amount of storage on a much smaller space these days. But when it comes to big data, I guess there's really no good definition for it. I like to say that big data can only be analyzed or processed by multiple machines or a supercomputer of some kind. But that definition probably is going to change as our technology changes too. So at some point, maybe our computers will be able to handle an infinite number of data queries and requests. So big data is kind of just turning into data, in my opinion. All right, so that is all I have for this lecture. Make sure you check out the website for any sort of class projects or homework assignments, and make sure you look out for the video for week 3, which will be talking about scrubbing data and analyzing data.